Studying and assessing the relative weights of cues is inevitable to understand a linguistic phenomenon. Ideally, cue-weighting studies would use large numbers of orthogonally varied cues to ensure fine-grained descriptions, combined with different lexicalisations to ensure generalisability. Such complex research designs are often not feasible since they would result in too high numbers of experimental tries per participant. Traditionally, studies focused either on varied cues or lexicalisations. A solution for still being able to conduct studies with both requirements might be active learning. Active learning can help to reduce the human labeling effort. A classifier can be built on subsequently labeled data, which we use to predict labels for previously unseen data. This means at a certain point we can simply use the classifier to predict missing labels. Furthermore, we can use the classifier to select stimuli for labeling wisely. We can query labels only for uncertain stimuli where the classifier is unsure which label to predict. As a result, the labeling process is speeded up since not all participants need to label all instances and the cues are updated by the system with each label. The figure shows the fictive outcome of a study designed with 4 orthogonally varied cues. We replicated this pattern with an active learning system. Virtual agents performed independent draws from a binomial function using the outcome scenario's probabilities as target. For updating the cue weights and prediction making, we used a linear regression model. The stimuli were selected according to uncertainty-based sampling. We analyzed the reliability and the speed of the replication. Regarding reliability, correlation analysis between the system's predictions and the responses of the agents revealed high correlations with low RMSE values throughout the whole labeling process and therefore high reliability. Regarding speed, we calculated the proportional change in RMSE to the previous 5 trials. The 5% threshold, which marks the point where the improvement becomes marginal, was reached earlier already after 12 of 64 trials. The calculation of the just proposed RMSE-based speed measure is only possible post-hoc. An online solution for stopping criterion is calculating the proportional change of the predicted probabilities to the previous 5 trials. With this measure, stabilization is reached after 70 trials, which is early in the labeling process and similar to the RMSE-based speed measure. Results show a reliable and fast replication of the target outcome pattern. The proportional change of the probabilities is a good indicator for stability in the ongoing labeling process. This makes active learning a promising solution for cue-weighting studies combining high numbers of orthogonally varied cues and lexicalisations.